All right, we're getting into chapter 2. And chapter 2 is going to start off here, lesson number 9. We're going to find domain and range of functions, and we're going to be talking about function notation, how things are written, and finding domain and range, something that we'll be doing throughout the semester. So let's start off with a function. So a function, definition-wise, is when every x value has a unique y value. So if you look at, say, a list of points, you essentially don't have any repeating x's. So no x repeats. Okay, so let's go through some sets of points to see which ones are functions and which ones are not. So a relation, by definition, is just a set of points. I'm not going to ask you, about relations. Mostly it's going to be functions, but these things are relations. So anytime the points have a repeating x, then you're not going to have a function. It will just be a relation. So for instance, this set of points here, which would be 1, 2, 1, 4, and 2, 6, we have the repeating x. So that one would just be a relation. 1, 8, 2, 9, 3, 10, all different x's for the different y's. That's a function. 6 to 100, 7 to 100, 8 to 100. Again, all the x's go to a different y. There's not a repeating x, so that one is a function. Even though you have repeating y's, that's okay. This one, 1, 2, 3, 1, 2, 3, that would be a function. Repeating 5s, that one would not. No repeating x's, that one is. Okay, so that's the difference between a relation and what would make something a function. If you're given the graph, then what we would use is what's called the vertical line test. This you should have seen in Algebra 2. If you have a graph drawn and you take a line and you go all the way across like I am right here, and it only hits the graph one time every time, that thing would be a function. This one down here would be an example of one. I can't get that to move, but you see it right here. This line hits the graph in more than one spot, so this would not be a function. This one would. Okay, so whether it's drawn like this one was, as a nice graph, or whether it's a set of points, it's still the same idea. So for function, not a function, again, if you do the vertical line test, so as I draw going down here, this one, your lines would only hit once. This one, you'd have one that hits more than once, so this one would not be a function. This one, obviously, if you draw going down, would not be a function. And this one would. All right. You're going to be doing some graphing and talking about domain and range. So the domain is where your graph stretches left and right. So the set of all of your possible x values, and the range would be y. So when domain, you're looking at x, range, you're looking at y. You can graph these either by hand or using Desmos or your calculator. You can kind of choose on that. If you want to know how to graph, say, absolute value problems, they make the V's. We're going to talk about what numbers do to those things in later on sections. So I'm not going to discuss that too much here. So for right now, if you wanted to, you could make a little XY chart and you could plug in numbers and see what would happen. This particular one would go like this. Okay, that should hit there at 0.2, excuse me. I drew that a little bit too high. So the domain on this thing, this graph stretches left forever and right forever with nothing missing in between. So the domain on this thing would be all real numbers. This is the symbol for all real numbers. You can write out the word all real numbers as well. That's perfectly fine. And the range would be anything 2 or greater, because range is your up and down, and this doesn't ever go below a y value of 2. So you would say y is greater than or equal to 2. Let's do another one. f of x is equal to the absolute value of x minus 3. That one, if you graph that on Desmos or by calculator or again by hand, will look like this. I need to redraw that. Sorry, that was not very good. Let me do this here. So there and there, what that one would look like. Okay, so again on this one, your domain, left and right, goes left forever, goes right forever, nothing undefined in between. And this one never drops below 0 when you're looking up and down. So your range would be y is greater than or equal to 0. All right, so now for a little function notation. This should hopefully be a review for you. This represents the x, so that means you take that number and plug it in for the x. So we would have 2 squared plus 3 times 2 minus 1. You can do that step by step if you want to. Do it in your calculator, however you'd want to do that. So that would be 4 plus 6 minus 1, so that would give you 9. That one. When you do f of negative 3, this one, when you plug it into your calculator, a lot of people do this one wrong. The negative is squared as well, so you need to put that in parentheses. If you don't, you'll get the wrong answer in your calculator. So this would be 9 minus 1, so that would be negative 1. And then when you do f of x plus 1, you're going to plug that in instead of an x. So instead of x squared, you would have x plus 1 squared. Instead of a 3x, you'd have 3 times x plus 1, and then the minus 1. And then with these problems, you multiply everything out. So if there's skills in some of this stuff that I'm going through here that I would assume that you would know and you don't, then I just wrote the exact same thing. When you're doing x plus 1 squared, that means to do x plus 1 times x plus 1. I'm going to distribute in the 3. Excuse me, that should be a 3. Erase that. That was not the eraser. Okay, x plus 1 times x plus 1 would be x squared plus x plus x plus 1 when you FOIL, or whatever the term was that you learned when you multiplied those out, plus 3x plus 3 minus 1. And then you would combine all of your like terms, and you will get x squared plus 5x plus 3. Okay? Last thing. All right, if I give you these two functions, I want you to do the following. So all of this means to do on this one is to, on part A, is to add the two functions together. B is to subtract the two functions. It does not mean to take the answer and multiply by x. This is just notation. Just like f of x doesn't mean to take everything and multiply it by x, f plus g of x is the same thing. Okay, so to add the two together, again, you would just add your like terms. And in this case, the only like terms are the 3 and the 1. So you would have 4x to the third plus 2x squared plus 4. When you subtract f and g, so that would be 2x squared plus 3 minus 4x to the third minus 1. Okay, so you're subtracting both of those terms. So negative 4x to the third plus 2x plus 2. Okay, multiplying them together is just like I showed you in one of the previous, I think it was the last slide there. You're going to take these two things and FOIL. So you would have 8x to the fifth plus 12x to the third plus 2x squared plus 3. That's what you would have on that one. And for the division, 2x squared plus 3 divided by 4x to the third plus 1. That is your answer. There's nothing else you can do with that because of these pluses and minuses. And this is something I'm going to talk about in class. You can't reduce when you have to be able to reduce with the whole term. You can't take the 2 and the 4 and reduce it to 1/2. Again, we'll go through that in class of why that's the case. That's a big mistake that a lot of people make, and I want to make sure that you're not making it. Okay. Then when you have these problems where you are, instead of having an x there, you have a number, what you're going to do is you're going to take what you just did here, and you're going to plug in the number for x. So for part E would go along with part A since it's addition. So I would have 4 times 2 cubed plus 2 times 2 squared plus 4. And if I do all of that, that'll give me 44. For the subtraction one, again, that'll go along with B. So negative 4 times 2 cubed plus, oops, I forgot a squared on that up there, plus 2 times 2 squared plus 2. And so when I put that in, I will get negative 22. From the multiplying one, when you plug 2 in for all of these x's here, again, I would do that right in the calculator, you're going to get 363. And when you put it in the division one, you will get 11 over 33, which will reduce to 130. Okay, so that is section 9. Let me know if you have any questions.